Hi everyone, welcome back to my channel. So today's problem of the day is count unguarded cells in the grid. So let me read the problem statement. You are given with two integers m and n representing 0 indexed m into n grid. You are also given the 2D integer arrays guards and walls where guards of I contains row I and column of I and walls of j contains row j and column of j. Represent the position of ith guard and jth wall respectively. A guard can see every cell in the four cardinal directions north, east, south, or west, starting from their position unless obstructed by a wall or another guard. A cell is guarded if there is at least one guard that can see it. Return the number of unoccupied cells that are not guarded. So let's take this input. So this is the input given for us. Now we need to consider m into n grid. Nothing but four with a grid which contains 4 rows and 6 columns. 3, 4, 5, and 6, and it also contains 4 rows. So I am drawing 4 rows here. So this is the grid we need to consider. Now let's mark the guards here. So guards is nothing but here one guard is there, 0 0, and 1 1. Here one guard is there, and 2 3, 0 1 2 3. Here one guard is there, and similarly let's also mark the walls here. Wall is 0 and 1. Here one wall is there, 0 1 2 comma 2. Here one wall is there, and 1 comma 4, 0 1 2 3 4. Here one wall is there. So now what they are saying is guards can see the all the direction, I mean north, south, east, and west, but they can't see through walls and another guards. So for suppose there is a guard here in this 0 comma 1, this guard can see this much straightward, and similarly there is also another guard here, this guard can see this much, and there is another guard here, he can see this much, this much, and this much. So now at last we need to count the number of cells which do not contain any guards. Let me take another color. So if I count the number of cells which a guards can't see, I'll get like this: 1, 2, 3, 4, 5, 6, 7. So there are 7 cells in total which the guards can't see. This is our problem statement, and 7 is the answer for this solution. So let's implement the Java solution for this. At first, I will declare a integer array which will store the arrays from which it is of length m into n. Let the array be ar equal to new int of m into n. So I got m into n grid. Now at first what I need to see is I will mark the guards and walls inside this array. For that I will take a for loop for int I colon guards if is not needed, ar of I of 0 and I of 1 equal to. So let's take guard as a 1. Wherever the guard is there, I will mark the guard as 1. And similarly for the walls also. For int I colon walls ar of 1 equal to. And I will also mark the wall as a 2. Let's take it as a 2. Now what I am supposed to do is I will iterate over the grid for int I equal 0, I less than m, I plus plus, and similarly for int j equal 0, j less than m, j plus plus. So whenever I encounter a guard, Then I will start the cells which he can see, and I will, what I'm going to do is I will mark the cells which the guard can see as a 3. Let's take two variables, row and column, just to store the I and j temporarily. At first I will assign row to I plus 1. I will take a while loop and I will assign the cells which the guard can see as 3. So while row less than n, as we are iterating from I plus 1 to n, first condition we need to check is the row should be less than n, sorry, not n, m, and here of row and j, and we should not get any guard in between the side of that guard. For that, not equal to 1, and we should not also get the wall in between his side. J not equal to 2. So there are three conditions. One, in order to check the row should be less than m, and one, there should be no in between guard and walls in between the side of the guard. So I will mark the row j as 3. These are nothing but the cells which the guard can see, and I will increment the row here. So I plus 1 is done. Similarly, we need to do for I minus 1. Row equal to I minus 1. Why? Here, when we are going upside, we need to check row should be greater than 0. And these two conditions is similar to that, not equal to 1, and AR of row j not equal to 2. And I will mark the cells which the guard can see as 3. And I will decrement the row here. Now I need to check the columns. At first we will iterate over the column plus 1. I mean right side. For that we need to check column less than n, and here of I column not equal to 1, and here of I column not equal to 2. Here of I column equal to 3. And I will assign the right side cells which the guard can see as 3, and I will increment the column. And similarly we should iterate over the left side also. Here column should be greater than 0. Here of I column not equal to 1, and here of I column not equal to 2. Then here of I column will be marked as 3, and I will decrement the column. So for now we have marked the cells as 3 where the guard can see. Now what we need to do is we need to count the cells which the guard can't see. I will declare a variable called answer which will indicate the count of the cells which the guards can't see, and I will take a for loop to count them. So if we see the grid, the cells which are marked as 1 contains the guard, and the cells which are marked as 2 contains the walls. The cells which are marked as 3 are the cells which the guards can see. but by default, the in Java, when we assign, I mean when we allocate the array, by default the values are 0. So the values which are 0 are the cells which the guards can see. So I will count the cells which are 0 inside my array, I mean grid. If I found anything, I will increment the answer. At last I need to return the answer. Let's compile and check. We got some error here. Sorry. It is passing the sample test case. Let's submit the solution. We got some wrong answer for some test case. Expected one, output is 3. So this is the reason why this code was failing. Here we need to check column greater than 0, not column greater than 0. Let's submit this solution. It's passing the test cases. Thanks for watching.